All right, let's talk about why most turbochargers really fail. And I'll give you a hint, it's probably not what you think. It has nothing to do with pushing too much boost or revving to the moon. Nope, it all comes down to their life support system, oil. And if you mess that up, a brand new turbo can be toast in seconds. Seriously.
So to really get why this is so critical, let's just think about the sheer speed we're dealing with. A turbocharger shaft, it can spin up to 300,000 RPM. Let that sink in for a second. 300,000. That's just wildly faster than pretty much anything else in your engine. It's a mind-boggling speed, and at that velocity, you need absolutely perfect lubrication. No exceptions.
Okay, so we have insane speed. Now let's throw in some brutal heat. The turbine side, the part getting blasted by exhaust gases, can get hotter than 800 degrees Celsius. So you've got this crazy combination of speed and heat. And in that environment, there is literally only one thing keeping that turbo from self-destructing.
And that brings us to the main point of this whole thing. Today, we're going to break down the real reason turbochargers fail. It's not about the boost, it's not about the RPMs. It's about the oil supply and drain mistakes that can destroy the bearings in just a few seconds. It's all about how the oil gets in and how it gets out. Yeah, you really have to think of the oiling system as the turbo's complete life support. It's doing two jobs at once. It's lubricating, of course, but it's also cooling. It's pulling all that incredible heat away. And honestly, it's the only thing standing between a healthy turbo and a catastrophic failure. The system is basically split into two halves, and they're both critical, but they work in completely different ways. So on one side, you've got the oil supply. This is a high-pressure feed line that's literally force-feeding oil right into the turbo's center housing. But on the other side, you have the oil drain. And here's the key difference. It's gravity return only. Its job is just as important. It has to get that hot, bubbly, used oil out of there. One is high pressure, one is no pressure. And a problem with either one, well, it's game over. So that high-pressure supply line, what it's doing is creating something called a hydrodynamic bearing. Now, this isn't what you might picture, like a ball bearing. No, this is much cooler. It's a super thin, highly pressurized film of oil. And the turbo shaft literally floats on it. It's suspended on this cushion of oil, which is what prevents any metal-to-metal contact. And that's the magic, but it's also the danger, right? The shaft never actually touches metal unless that oil pressure drops. Think about that. At 300,000 RPM, it's just floating there. But if that pressure disappears for even a split second, that protective oil film collapses instantly. Okay, so what happens when that oil supply gets compromised? Let's dive into some of the most common supply-side problems, the things that can starve a turbo of its lifeblood. Well, you could have low engine oil pressure, which means that protective film just can't form properly. Or the feed line itself could be restricted or blocked, maybe with sludge or carbon buildup, which just chokes off the supply. Using the wrong kind of oil, the wrong viscosity, that can be a killer too, because the film won't be strong enough at high temps. And one of the biggest ones, a dry start right after installation. That means zero lubrication the first time that shaft spins up. Ouch. And you know what? The consequence for any of these is exactly the same, and it's ugly. That oil film collapses. You get metal grinding on metal at unbelievable speeds, and the turbo just seizes up. This isn't something that happens over months. We're talking about an immediate catastrophic failure. Seconds. That's all it takes. But look, oil supply is only half the battle. Now we've got to talk about the drain side. And honestly, these problems are probably even more common, and definitely more misunderstood. This is where the mystery of most turbo oil leaks actually begins. Okay, so remember what we said. Oil is forced in with pressure, but it can only get out with gravity. That is so important. This means the drain line has to be a perfect, clear, downhill shot with absolutely zero restrictions. Any blockage, any little kink, any obstruction at all, and that oil has nowhere to go. It just backs up and starts flooding the turbo's center housing. So here's what a good drain flange looks like. See that? It's got an integrated O-ring. This is the right way to do it. It creates a perfect seal, but nothing can squish into the drain path. It guarantees you have a wide open, completely unobstructed path for that oil to get out. Now, let's talk about the single biggest mistake people make, using liquid gasket, RTB silicone. The problem with RTV is that when you tighten that flange down, the extra gunk has to go somewhere. And it squishes inside. It gets right into the oil path. Not only does that block the flow right at the turbo, but little bits can break off and plug the line even further down. Just don't do it. Never use silicone on a turbo oil drain. And this
This is what happens next. When that drain is blocked and the oil starts backing up, it has to go somewhere. So the pressure builds up inside that center housing, and it literally forces the oil right past the seals. It gets pushed into the compressor housing on the cool side and the turbine housing on the hot side, and that's when you see that classic, massive cloud of blue smoke. That's oil getting burned where it shouldn't be.
This all brings us to what is maybe the single most important engineering idea you have to understand when it comes to turbos. It's called the pressure balance principle. So you see oil coming from your turbo, or you're getting that blue smoke. What's the first thing you think? Ah, the seals must be bad. I've got a blown seal, right? That's the go-to diagnosis. But are the seals really failing? The answer is almost always no. This is the big reveal. Turbo seals are not rubber seals like you'd find on a crankshaft. They're totally different. They're dynamic seals. They look kind of like tiny piston rings. And here's the ticker. They're designed to work only when the pressure inside the turbo center section is lower than the pressure outside of it. So when things are working right, you have stable crankcase pressure and there are no leaks. But if you have a blocked PCB system or a lot of engine blow-by, you get high crankcase pressure. Or if you have a blocked drain line, both of those things raise the pressure inside the turbo. That pressure then literally pushes oil right past the seals. So the leak isn't the problem, it's a symptom of a pressure imbalance. The seal didn't fail, the system failed the seal. Okay, so now that we know what's really going on, how in the world do we prevent all these problems? Let's run through a quick but absolutely essential checklist. Call it the Turbo Survival Guide. First, always prime a new turbo before starting it. Fill it with fresh oil and crank the engine over with the fuel cutoff to build oil pressure first. Second, idle the engine before you shut it off, especially after a hard run. Give it 30 to 60 seconds. This stops the oil from cooking inside the turbo, a process called coking that blocks passages. Third, if you're replacing a blown turbo, you must replace the oil feed line. Don't just try to clean it. You'll never get all the debris out. Fourth, check your engine's breather system. Make sure the PCV is clean and working right to avoid high crankcase pressure. Fifth, use the right oil. High-quality synthetic with the exact viscosity the manufacturer recommends. No compromises. And finally, I'm going to say it again, no silicone sealant on any oil flanges. Use the proper gaskets or O-rings, period. Look, the bottom line is this. In turbo engines, oil flow isn't just maintenance, it's survival. It's not just another thing on a checklist, it is the absolute foundation that keeps that component alive. A turbocharger is an incredible piece of engineering built to handle insane stress, but it is 100% dependent on its life support system. So protect the oil system and the turbo will last, but ignore it and failure isn't just a risk, it's an absolute guarantee.